this is a GCSE misconception question. It's taken from P5, which is light in the electromagnetic spectrum part of the course, and specifically it looks at a core practical which investigates radiation and which colours are best at absorbing and transmitting infrared radiation. So the question is all about a water cylinder, a copper cylinder. It's got a foam jacket on it, and a company's developed a new material which they think could be used instead of the foam around the cylinder. And you've got to devise an investigation that could carry out to make a fair comparison of the insulating properties of the new material with those of the foam. So it's a 6-mark question, and it wants you to devise an investigation. So you've got to think back here to the core practical that you would have done in P5, or possibly you might have read about it in P5, and really just describe how you would carry out that practical. The way the question will be marked, so there's a level 1 response, which would get you between 1 and 2 marks, a level 2 response, which would get you between 3 and 4 marks, and a level 3 response, which would get you between 5 and 6 marks. So let's have a little look at how we're going to answer this. So right the way through, we need to kind of come up with a bit of a method and describe what we're expecting to see and how we would carry the experiment out. So to start with, we're going to have a little look at what apparatus we might need. So we might need some beakers, probably 2 beakers, or we might put down perhaps 2 boiling tubes. Now you probably would have done this if you did it in a lesson, or you looked at the textbook. You would have used boiling tubes. You would have used a thermometer to record the temperature. You would have used a stopwatch, and you would have used the insulation. In this case, it would be the foam jacket and the new material. Okay, so it's 2 types of insulation, and you can pretty much use this answer to answer any similar question to this. So now we're on to kind of describing how we might do the experiment. So we're going to put the material around the cylinder, or around our beaker or our boiling tube. So we're going to put our material around it. And you can talk about this in terms of beakers or cylinders. It doesn't have to be, or boiling tubes. It doesn't have to be specifically about the cylinder. You then add your hot water. You'd probably want to measure the start temperature. You'd then want to measure the temperature at certain intervals. So you'd record the temperature. At certain intervals. So every 2 minutes or 1 minute. And then you'd want the final temperature. And then you would work out the difference between the start and the end temperature. So that would give you an idea of how you do the practical. Now you need to compare them. So you would change the material, so you'd swap the material around, put your other material around it. You'd repeat the experiment but with fresh water, but keep all the other variables the same. So repeat the experiment. And you would record your results. And then you would compare them. So the one that cools down more slowly is the best insulator. So one that cools more slowly is the best insulator. Or you might talk about the one that is the hottest at the end, still the hottest at the end. That would be the best insulator. It asks about making sure that how you make sure it's fair comparison. So there's got to be a little bit about how you make sure it's a fair test. So running all the way through that, things like you keep the same. You'd want the same mass of water. So you want the same mass of water. You'd want the same thickness. of material. And you don't have to mention all of these, but mentioning a couple would do the trick. The same starting temperature, and you'd want probably something like the same interval, and the same room temperature would also be quite a good one. How would you improve the accuracy of the experiment? So you would take repeat readings and you would determine an average. Now that answer can be applied to any question which looks at the core practical on investigating radiation and cooling. In terms of picking up level 1 or 2 marks, I think if you had a little bit of an idea of 1 or 2 bits of equipment you might use, and you might tell me that you'd wrap it around and let it cool down and tell me which one's the best, you might pick up 1 or 2 marks. If you were looking at 3 or 4 marks, I'd expect a bit more detail about the equipment as well. I'd certainly expect more detail about how you do the experiment in terms of start temperatures, a bit more detail about repeating the experiment with the second type of insulation, and probably then tell me something a little bit about how you're going to keep it a fair test. And then finally, to get the full marks, I'd expect you to give me pretty much a full list of equipment, pretty much detail around how you're going to do the experiment and what the experiment would show you. And I'd certainly expect some detail around how you're going to keep it a fair test, and then probably also just a mention as well about repeat readings. Cover all of those things, or the majority of those things, and you'd pick up the full 6 marks.